The new simulation environment, VINcoSIM, is based on a unique simulation core, which makes it possible to simulate every module and every topology under various conditions. Just select the module of interest from our webpage with an existing simulation model. If the simulation model is not implemented already, you may request it. Once registered and logged in, the simulation will start up in the dedicated power module. Compared to ISE 3, the new simulation environment is an online tool. No third-party software has to be installed, which makes it independent from the operating system. All main power module properties are shown at the very top, giving information about the module capabilities and, for example, the type of thermal interface material used during characterization. This also means that simulation results are based on datasheet values, and that these are always based on the latest datasheet revision. Some of the sections can be collapsed to save space or to focus on information of interest. Firstly, the environment has to be specified. This can be a fixed heatsink temperature or even a customized heatsink, following the R and tau values for a Foster model. The most important part of VINcoSIM is the simulation setup. Our selected power module is divided into different elements: the rectifier, the brake chopper, and the inverter. Each element has its own input and output parameters, and each element works independently from the other. I buttons give additional information and hints. In this example, it shows where the input voltage is referenced, the output voltage, and current. In addition to the parameters, the control values must also be set. Whereas parameters are the power values, the control section determines how to drive the component. Once all settings are configured, clicking the Run Simulation button triggers the simulation core. A green information bar appears if the simulation converts. Simulation results are divided into a summary where only junction temperatures and loss are shown. But you can also find details of where further results can be found. The very top shows the apparent output power for the inverter stage. The sum loss is the summation for the loss of all elements inside the power module, and the apparent efficiency is valid for the whole module. Here we see the total loss of all rectifier diodes, and the highest average junction temperature of a single component. As we have more components in the inverter element with different functionality, two values are shown. One for the inverter switch, and the other for the freewheeling diode. At the very bottom, the efficiency of each stage is displayed. Finally, a PDF report is available for download with all settings and results. The simulation details consists of further information about the loss of each functional component, as well as the junction temperatures. Similar to the product selection and environmental settings, each functional component can be hidden or revealed. Finally, the last section of the simulation details outlines different component performances with information like component loss and junction temperature swing. At the top of this section, different functional components can be selected. Moving to the end of the page, individual waveforms for voltages and currents of selected functional component are displayed. Simulation conditions and simulation results are available in a PDF report, which can be generated in the same way as simulation summary.